Hello scholars, welcome. Mr. Hinkle here. We're talking about primary productivity, the basis of marine food webs. And it seems like, hey, it's all good. Marine life needs food to survive. But there is a darker side to biological productivity in the form of negative impacts, of which we are going to discuss here. We're really looking at the process of eutrophication that leads to marine dead zones. Dun, 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 dun. I know, it's as bad as it sounds. So, quick review. The creation of new organic matter in the oceans happens through primary productivity, also known as biological productivity. It's basically microscopic marine algae photosynthesizing, creating sugars and oxygen. Well, if there's too many photosynthesizers, marine phytoplankton, then a harmful algal bloom can be created. So this is an overabundance of diatoms or dinoflagellates. So let's go here. This is, you guessed it, marine provinces. And primary productivity needs light and nutrients. Well, in certain areas, coastal regions, we can have an abundance of light, and the process of upwelling can bring an abundance of nutrients. Nutrients, light, we'll call this NPP, net primary production. Well, this is going to feed marine food webs. That's awesome. But if there is excessive nutrients, we'll say plus, 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 then that can lead to plus, 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 a bloom of excessive dinoflagellates, of excessive phytoplankton. This is caused by terrestrial runoff that leads to algal populations that in high enough concentrations can change the water color. Here we see harmful algal bloom off of San Diego, creating what's known as a red tide. This came up better on my computer. You can't really see it, but this is basically all red. Red tides are HABs that produce toxins. These toxins can get into the fish. The fish can be consumed by people. The people can be subject to paralytic shellfish poisoning. This is a thing that happens. Too many nutrients in the water lead to overabundance of photosynthetic primary producers, which causes a harmful algal bloom that makes its way through the food web. This makes sense, and this is one of the negative impacts of primary productivity. So here we can see a harmful algal bloom literally being scooped out of the water. This is in China before the 2008 Olympics. Goes like this. The process of eutrophication. Key word here. Eutrophication. So we grow food on land, in farms. And the process of growing food uses the nutrients in the soil. Well, if we want to use those same fields again, then the practice is to put nutrients back into the soil through fertilizers. Well, as we fertilize the soil and then it rains, those fertilizers can be washed into water courses, which eventually make their way into river systems that eventually flow into the ocean. So we'll say these are fertilizers. After heavy rains in specific growing seasons, these fertilizers make their way, and here we have our excess nutrients. So harmful algal blooms that occur because of excessive nutrients from the fertilization and other sources in terrestrial environments will lead to the process of eutrophication, ultimately creating dead zones where you have hypoxic or oxygen poor waters, or anoxic, which means without oxygen, killing all of the marine life that need oxygen to survive. It goes a little bit like this. So, dissolved oxygen in the river and the ocean, all good, healthy ecosystems. Well, fertilizers, sewage, nutrients from farming flow down the rivers into the salt water. Nutrients, one of our two limiting factors for primary productivity, allow for a harmful algal bloom, algae to grow into significant quantities. That algae starts to lower the dissolved oxygen. Well, as that algae dies, it goes down to the bottom, and then decomposers actually thrive off of the decomposing material, using up dissolved oxygen in the water column. And what remains is water that has been the oxygen removed, right? So the dissolved oxygen, if we're looking in parts per million, goes from 8 to 7 to 4 to 2, maybe even to 0. This is the process of eutrophication. Artificial fertilizers making their way to the ocean, causing harmful algal blooms, which leads to dead zones, areas in the ocean that no longer have enough oxygen to support marine life. And so globally, there have been 500 dead zones recognized all over the world. The size and number is increasing, and they're connected to areas of large human, what am I trying to say? So where people live and where people farm, this is where dead zones are, right? So they're connected to high population density. There's the word I was looking for. And there's a correlation between population density and dead zone size. The Gulf of Mexico collects water from the entire Mississippi River drainage. And this drainage basin covers, half of the United States. All of the fertilizer put on all the farms here in the Midwest eventually makes its way to the Gulf of Mexico. And then that can create a seasonal dead zone. So this is the process. Fertilizer on the fields washes into the rivers. That fertilizer brings nutrients. When you have the spring bloom and the fall bloom, those nutrients and sunlight create so much primary productivity that it leads to a harmful algal bloom. This is eutrophication. And that harmful algal bloom will end up removing dissolved oxygen from the marine environment, depleting the bottom of the water of oxygen, creating a dead zone. So the Gulf of Mexico dead zone is the second biggest dead zone in the world, about 8,800 square miles. Recently, though, the Arabian Sea dead zone was discovered. Scientists couldn't get in there because of conflict and piracy. I just love that I have a slide that I can say, we didn't know about it because of pirates, but this is a thing. This dead zone is the size of Florida. It's in the Gulf of Oman, south of Iran, and it is 63,000 square miles. So this is a huge dead zone. These are big issues. 500 dead zones all over the world, some of them massively huge. So what do we do? Because this is a problem, and our oceans shouldn't have dead zones to this magnitude. So really, we have to watch the flow downstream. This is an example that what we do on land impacts our oceans. Now, I live in Fresno in the Central Valley of California, and I get to the ocean a couple times a year. I can't see it. I teach it, I love it, I think about it, but in my daily life, I don't see it. So the oceans feel like they are a little bit out of sight, out of mind, but everything I do, from where I put my trash to what I put on my yard, which is not fertilizers or glyphosate, because those have extremely damaging adverse effects, is going to affect the oceans because it flows downstream and the downstream ends in the oceans. So in order to minimize our impacts in the oceans, you and I can think about what we're doing on land. For farmers, nutrient runoff. For all of us, preserving wetlands, buffer strips, crop rotation, clean water regulations, choosing where we buy our food, supporting organizations that are working towards cleaner, healthier ecosystems. There's a lot of things that you and I can do to help minimize the damage and the destruction of dead zones. But the first, and maybe the most important, is educating yourself, understanding how these things function, and that this problem actually does exist in the world. So let's do a quick little review of what we're discussing here. Primary productivity needs light and nutrients. And this is a good thing. It forms the basis of marine food webs. But with excessive nutrients, there can lead to an overabundance of primary productivity that creates a harmful algal bloom. Now, with all that excess algae, when it decomposes, it removes oxygen out of the marine environment, leading to a dead zone. Dead zones are globally distributed. There's over 500 of them worldwide, and they're a big issue, something for you and I to think about and take proactive steps in our daily lives in order to help, support, and overcome this problem. So, thank you so much. I'll see you again.